I'm Anil Kumar. Welcome to my series on linear systems. Let us first try to understand what are the prerequisites. We'll kind of review a few concepts learned about lines in this particular video. Now these are very important for you to understand before you begin with linear systems. We'll solve 6 questions to understand all the concepts required. Question number 1 is determine slope of a line x plus 2y equals to 6. Question number 2, find equation of line passing through minus 4, 3 with slope 0.75. Question 3, find equation of line passing through the points minus 2, 3 and the origin. Question 4, find 4 points on the line 2x minus 3y minus 6 equals to 0, including intercepts. Question 5, solve for the indicated variable. So we have 3 types of linear equations involving some fractions. Question 6, sketch graph of following lines. And now let's take their solutions one by one. Question number 1, straightforward. Determine slope of a line x plus 2y equals to 6. So let's write this in the form of y equals to mx plus b, right? So we need to isolate y. So we can write this as 2y equals to minus x plus 6. Y is equals to minus half of x plus 6 divided by 2, which is 3. Now in this case, slope m is equals to minus half, right? So that is the slope. So in this equation, y equals to mx plus b, m is the slope, right? So that is how you figure it out. Find equation of line passing through minus 4, 3 with slope of 0.75. So we are given slope m as 0.75 and we are given a point which is minus 4, 3. Now 0.75 can also be written as 3 over 4, right? You could say 75 over 100 and then 3 over 4. Now we'll use this equation y equals to mx plus b to get the equation. Slope is 3 over 4, so we get y equals to 3 over 4x plus b. Using this point, we can find value of b, the y-intercept. Minus 4 is the x value, 3 is the y value. So we get 3 equals to 3 over 4 minus 4 plus b, right? Let's take it on the right side to solve further. Now 4 minus 4, when you divide, you get minus 1. So we can write this as 3 equals to 3 times minus 1 plus b. Taking this to the left side, we get 3 plus 3 equals to b, which is 6. So if b is 6, then the equation will be y equals to 3 over 4x plus 6, correct? So that is how we get our linear equation. Right? Some of you could also use the other form of the equation to get the solution of this question. The other form of the equation is, let's use different ink. You could use the equation y minus y1 equals to m times x minus x1. So in this particular case, we get y minus y value is 3 equals to m, which is 3 over 4, over x minus x1, which is minus 4. So it becomes like this. So we can now cross multiply. So we get 4 times y minus 3 equals to 3 times x plus 4, which is 4y minus 12 equals to 3x plus 12. Now bringing them together, we could write in standard form. So we could write this as 3x minus 4y, and that is plus 24 equals to 0, right? Now you could divide everything by 3 to write the final answer as, when you divide by, well, let's leave it like this. You cannot divide 4, so that is what our result will be. Perfect. So this is the standard form, and that is slope-intercept form for the same equation. Is that clear to you? Now let's take question number 3, which is Find equation of line passing through the point and origin. So that is like direct variation, right? So we have a line which goes through minus 2, 3, so somewhere here, right? And the origin, right? So it goes like this. So slope, it is a negative slope. Let's say this point is minus 2, 3. So we know that slope m will be equals to, well, let's first consider the 2 points. M will be y2 minus y1 over x2 minus x1. We have a point P, let's say, which is minus 2, 3. And the other point Q is origin itself, right? And therefore, we can write slope m as 3 over minus 2, right? Or you can say 3 minus 0 over minus 2 minus 0. But basically, it is 3 over 2, right? With a negative sign, right? So that becomes the slope of the line. And since the y-intercept is origin, we know y equals to minus 3 over 2x, right? You would actually write this equation also in standard form. Sometimes we need to write them in standard form. So cross multiply, we get 2y equals to minus 3x, or you can say 3x plus 2y equals to 0, right? So that becomes your solution. So I hope the steps are absolutely clear, right? Now let's take up the next question, which is question number 4 for us. Find 4 points on the line 2x minus 3y minus 6 equals to 0, including intercepts. So let's talk about x-intercept and y-intercept also. Right? So x-intercept is a point where y equals to 0. Y-intercept is a point where x is equal to 0, right? So the equation of the line is given to us. We could rewrite this as 2x minus 3y equals to 6. Now in this equation, if I substitute y equals to 0 here, I get 2x equals to 6, x equals to 6 over 2, which is 3. So x-intercept basically is 3, 0, right? As far as y-intercept is concerned, we can substitute 0 for x. We get minus 3y equals to 6, or y equals to 6 over minus 3, which is minus 2. So the point for us is 0 minus 2. Is that clear to you? Now if you are supposed to sketch this line, once we have found these intercepts, which are at 3 and minus 2, so something like this, right? So we have a line here, y-intercept is at minus 2, x-intercept is at 3. So we could also sketch this line. Well, this is not the part of this question. However, we're kind of reviewing the concepts, so it is good to understand as we move along, correct? Okay, so we got 2 points. We need to find the other points, right? How could we find other points? Well, one way is you just substitute any value for x and find the value of y, right? You could do that. Or you could write this in slope-intercept form. So what you may do here is we have 2x minus 3y equals to 6. Let's rearrange. We get 3y equals to 2x minus 6. So I take this on right side, 6 on the left side. Dividing by 3, we get y equals to 2 over 3x minus 2, right? So that becomes our equation. Now we can have a table of values, right? So we need just 2 more points. We already have 2 points here. So if I substitute, for example, x equals to 3, let's write x equals to 3 is better since that will cancel away. So y equals to 3 and 3 cancel, 2 minus 2, which is 0, right? So we already have that point, x equals to 3. Let's take x equals to 6. So if I write x equals to 6 here, we get y equals to 2 times 2 minus 2, and that value is basically equals to 4 minus 2 as 2, right? So we get another point which is 6 and 2, right? Now to get one more point, let's write x as equals to minus 6, right? So if I write minus 6 here, in that case, in this equation, we are always using this equation now. So if I write minus 6 here, 3 times minus 2 is minus 6, right? So what we get here is y equals to 2 times, so it goes minus 2 times, right? Minus 2. So we get a value of y as minus 4 minus 2, which is minus 6. So the point is minus 6 minus 6, correct? So we get 4 points, and the 4 points, now let's summarize these 4 points, are the two intercepts, which is 3, 0, and then we have 0, minus 2, and these two at 6, we got 6 and 2, and at minus 6, we got the value as minus 6, correct? So that is how we could answer this particular question. So now let's look into the question number 5. You can always pause the video, answer this, and then look into my suggestions. Question number 5 involves finding the value of x. We have 3 parts in it. So let's begin with the very first one. We need to solve for the indicated variable. The variable here is only one, which is x, right? So let me write x. So we need to isolate x. So let's expand this. We can write this as 3 minus, open the bracket, so we get minus 3x, minus minus is plus, so we get plus 3 equals to 5 times 2, 10x plus 5. Bring the x terms together. So let's take this on the right side. 3 plus 3 is 6, right? So we have here, let me rewrite this as 3 minus 3. We'll take 5 on this side, okay. And we have 10x plus 3x, right, so which makes it 13x, and here we have 3 minus 3 is, sorry, 3, this is plus 3, I'm sorry, minus 5, so 6 minus 5 is 1, so we get 1 over 13 as the value of x. Clear? Part B is half of x minus 1 equals to 1/3 of x plus 1. So let's cross multiply. So the strategy here will be to cross multiply. So when you cross multiply, you get 3 times x minus 1 equals to 2 times x plus 1, correct? So that is 3x minus 3 equals to 2x plus 2. Now 3x minus 2x is equals to 2 plus 3. So which is x equals to 5, right? So we get x equals to 5 as our solution. Part C again involves fractions 9 and 5. So in this particular case, we have lowest common denominator is 9 times 5, which is 45, correct? So we can take 45, we can multiply every term by 45, we could do that, right? So multiply each term by 45. So we could think like this: 45 times x minus 3 over 9 plus 45 times x minus 2 over 5 equals to 2 times 45. Clear? Now the idea was to get rid of fractions. So that goes 5 times and this goes 9 times. You could even apply cross multiplication strategy, right? So alternate will be cross multiply. Okay. So let's multiply. So we get 5 times x minus 3 plus 9 times x minus 2 equals to 2 times 45, which is 90. Open the bracket. So we get 15 here plus 9x minus 18 equals to 90. So 5x plus 9x, let's write down. And take the constants on the other side. So we get plus 15 plus 18. 5 and 9 is 14x. And here 8 and 5 is 13, 3, 1, 10, 11, 12, 123x, right? So x is equals to 123 over 14, correct? So that is what our answer is. So you could actually leave it like this, or you could try simplifying it if possible, right? So I'll prefer to leave it just as this. Let's move on and take the next question. This is the last question, question number 6, where we need to sketch graph of following lines. So we have taken 3 cases. So let's try to sketch the graph here. Okay. The first one is 5x minus 3y minus 1. How will you sketch this line? So let's do it here. So we have 5x minus 3y. Let me take 1 to the right side. So we get 1 here, right? So whenever you're given in this form, it's good to find x and y intercepts, right? So what is the x-intercept? X-intercept will be substituting y as 0. So we get 5x equals to 1, or x is equals to 1 over 5. So that means, let us say this point is 1 over 5, x-intercept, right? Now let us find y-intercept. Y-intercept means x equals to 0. So if I substitute 0 here, I get y equals to 1 over minus 3. So we get y equals to minus 1 over 3. Let's say this point here is minus 1 over 3. So the line will be joining these 2 points, x and y intercepts, and we could draw a line like this. So that will be my rough sketch for part A, right? So in part A, the strategy was what? Strategy was to use intercepts. Okay. Now let's do question number 6, part B. Line perpendicular to y equals to 0 passing through the point 1 minus 2. Well, that is fairly straightforward. However, that may create confusion at times. So we have a point here 1 minus 2, right? Let's say that is the point which is 1 minus 2. Line perpendicular to y equals to 0. Now which line is y equals to 0? This line here is y equals to 0. The x-axis. So y equals to 0 is basically x-axis. Every point on the x-axis is y equals to 0, and that's how you get this equation. Is that clear to you? Now perpendicular to this means it is a vertical line. Perfect. So it has to be a vertical line going through the point 1 minus 2. So that will be the line for us. Okay, so let this be the point. So the equation of this particular line, vertical line, is going to be x equals to 1, right? So x equals to 1 will be the equation of this line, and that is how you're going to sketch it, correct? The part C is y equals to 2x minus 1, where x is greater than or equal to minus 1 and less than or equal to 2. So that means it is bound, right? So we'll not put arrows on both the ends, right? Normally we put arrows on both the ends. In this case, we should make a table of values, right? So in our limited space, what I'm going to do here is that, okay, so we have some values here, let's say. Okay, so we'll take some values and calculate. So we'll take x values as minus 1 and 2. These are the two boundaries, and calculate y, right? So y, which is equal to 2x minus 1. So if I substitute minus 1 here, I get 2 times minus 1 as minus 2 and minus 1, which is 3, right? If I substitute 2 here, I get 2 times 2 is 4, 4 minus 1 is 3, correct? So the coordinate points are minus 1 and 3, and also 2 and 3, correct? So those are the, minus 1, minus 3, yeah, and 2 and 3. Okay, so using these 2 points as our extreme points, we can actually sketch. So minus 1, minus 3. So we have minus 1 and let's say 1, 2, 3. So that's one point. And second one is 2 and then 1, 2, 3. Correct? So joining these points, we get our line. Oh, sorry. So these are the endpoints. I'm sorry. No arrow here, right? Okay, let's redo this. So these are the extreme points. So it ends here and that becomes our line. Okay. So let's call these points as our 2 extremes. So that becomes at minus 1, this is at 2, and the values which we get is 3 and minus 3. Is that clear to you, right? So that becomes the line for case 6C. So when you have a boundary condition given, you need to just place the line within that particular boundary. Now, since we had greater than equal to sign, so we have filled in ends. So this segment is bound at two ends. So on the left side, it is -1, -3, and on the right side, it is 2, 3. Perfect. So I hope all the steps are absolutely clear. We have done a variety of examples which should help you to begin with linear systems. That's the whole idea. So in the next video, we will see what linear systems are and how to solve them. I'm Anil Kumar, and I hope you understand and appreciate our effort in this particular video. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.